Myself, Mark, and as Pang data scientist. I have built new machine learning project that is credit risk modeling. The main idea behind this project is to help finance officials to identify credit risk associated with each applicant. In this presentation, we will discuss what are the project objectives, success criteria, and methodology part. After that, we'll discuss what are the machine learning algorithms that we have used to train our model and some model evaluation metrics. At last, we'll see stability by application for the same. So let's begin with the project objective. Our first objective is that develop an automated credit system that measures the likelihood of loan default and credit risk. To identify loan default and credit risk, our model will give us a certain criteria. Firstly, it will give us the probability of a person being defaulted, and it also generates a credit score between 300 and 900 that signifies the creditworthiness of an applicant. It also provides rating to each individual, that is poor, average, good, and excellent, based on the credit score. What are the success criteria? The major success criteria is that the recall on default class should be greater than 90%. The model must identify majority of our defaulters, that is actual positive. Model should not predict applicant as a non-defaulter who is default. In finance sector, we have one major problem that if a loan official has provided a loan to an individual and that individual is not able to pay the loan money back, in that case, we need a high recall to identify majority of a defaulter. Precision on default class can be greater than 50% because model can miss some of the non-defaulters as it can be identified by further analysis. In this particular situation, we can have a lower precision, but we need a high recall. Our next criteria is that AUC and Gini coefficient should be greater than 85%. High AUC and Gini coefficient depicts our model performance, that it is able to distinguish between both the classes. Next is KS statistics should be greater than 50%. Generally, the KS statistics is greater than 40%, and the maximum KS lies in the first decile, then we can say that our model is performing really well and it is able to distinguish between both the classes. Last criteria is that the model should have high level of KE explainability. We need some coefficients so that this coefficient can be used in the future to improve model performance and do some necessary changes. Let's see what are the dataset that we have used. We have used three datasets: customers, loans, and bureau. Each dataset contains 50,000 records. First is customers dataset. This contains all the information regarding customer, like what is customer ID, gender, number of dependents, residence type, etc. Our next dataset is loan dataset. It contains the information about a loan that an individual has taken. It contains loan ID, the purpose for a loan, type of loan like secured and unsecured, what is the loan amount, and what is the principal outstanding, and default that is our target variable. Our last dataset is view dataset, contains information like number of open accounts and close accounts for the customer, total loan months, delinquent month. Months are the number of months in which the customer has paid the installment after due date, total due past days, and credit utilization ratio. Now we'll discuss methodology part. It contains all the information that what are the steps that we have taken in building this project. We have discussed about dataset. Next is data preparation and EDA. At first, we have split our dataset into 75% training and 25% dataset. We have some data cleaning like we have inputted some null values with resident types. We have picked some non-invalid data and we have plotted some kernel density and box plots to visualize the features. After that, we have done feature engineering, which is the major part before any model training process. We have done two processes. We have done feature creation and feature selection. Feature creation is done with the help of domain knowledge and business understanding. And feature selection is done with the help of processes like information value and variation inflation factor. I have done min-max scaling on continuous features and encoding on categorical columns. After that, we have done model training. These are the models that we have trained: logistic regression, XGBoost, random forest. And then we have done some fine tuning to come up with the best parameters for our model. I have used techniques like random search CV, grid search CV, and Optuna. For model evaluation, I have XGBoost classification report, AUC ROC curve, KS statistics and Gini coefficient, and at last we have deployed on Streamlit Cloud. Let's see the data preparation part. As discussed, we have splitted our data set and we have done some imputations in residence type. These are the box plot and kernel density plots to identify some of the outliers. I have attached some box plots and histograms. As you can see that the histogram plot is compressed and rightly skewed, leading to potential outliers. We have removed records having the ratio of processing fees and loan amount less than 0.03. We have done some loan processing column fixation. Next is feature engineering part. We have created some features that can have the good dependency on our target variable. It contains loan to income ratio, delinquency ratio, and average DPD per delinquency. As you can see in the kernel density plot attached below, that these created features is able to distinguish our both default and non-default classes. For the less values, we have less defaulters. After created features, we have done some feature selection. Features are selected based on business understanding and two techniques like Gaussian inflation factor and information value. Based on domain knowledge and business understanding, we have dropped some columns as these columns are used to create some additional features. If we did not drop them, they will make the problem of multicollinearity. Features having inflation factor greater than 10, we have dropped them to handle multicollinearity. And these includes like GST processing fees, principal outstanding and sanction amount. And the features having information value less than 0.02 are also dropped as they does not have significant impact on our target variable. These are the significant variables that are finalized for our model training. As you can see that credit utilization ratio, delinquency ratio, and loan to income ratio has very high information value, indicating that these features have a significant impact on our target variable. And on the other hand, age and number of open account does not have significant impact on our target variable. Let's discuss the models that we have created. We have basically made three attempts. In attempt one, we have trained logistic regression, random forest, and XGBoost without class imbalance. We have done hyperparameter tuning with the help of randomized search CV, which take random parameters and train our model. In attempt one, XGBoost performed well with the accuracy of 96% and the column default class as 82%. In attempt two, both logistic regression and XGBoost are trained, and the class imbalance is handled using undersampling. In attempt two, XGBoost outperformed logistic in case of recall, giving us the default recall as 98%, and both these models perform poorly on precision. In attempt three, models are trained with the help of Optuna hyperparameter tuning. This provides us the directional approach instead of using some combination of parameters or selecting some random parameters. It gives us the best parameter. And the class imbalance is handled using SMOTE Tomek technique. In attempt three, logistic regression provides better recall of 93%, but XGBoost gave relatively better F1 and accuracy. So after making three attempts, we have finalized our model, and our model is trained on the logistic regression algorithm. Although XGBoost provide good results in case of accuracy and F1, but as our business needs and success criteria, we need a high recall and high AI explainability. For that, we have used logistic regression. Let's discuss some of the evaluation metrics of our logistic regression. It gives us the accuracy of 93%, with the recall as also 93%, and F1 as 83%, and AUC and Gini coefficient as 98 and 96% respectively. F1 macro as 83% shows that our model is able to capture both precision and recall effectively. These are the important graphs after model training. First is the future importance graph. It shows that loan to income ratio, credit utilization ratio, and delinquency ratio are the major predictors of our default variable. And on the other hand, residence type as owned and loan purpose as home has a negatively impact on our target variable. Our next curve is ROC-AUC curve. As you can see that this plot aligned towards left with the area is 98% shows that our model is able to handle both true positive rates and false positive. Next is KS Statistic. As you can see that 85%, 85.8 as maximum KS lies in the second decile that shows that it is able to capture both default and non-default classes. Now let's see streamlity application. This is our streamlity application. These are the features that we have already discussed, and I have given some other values. For this particular individual, will calculate the risk. It will give us the default probability as 63% with the credit score as 500 rating with a rating as average. As we have discussed that loan to income ratio and credit utilization ratio have significant much impact on our default probability, and it's obvious that if the person is asking more loan money and he does not have much income, then the default probability will going to be increased. I have increased the loan amount. It gives us the loan to income ratio as 21%. If we calculate the risk of this individual, it will give us the probability of being a defaulter as 100% and poor credit score as 300. So that's all for this project. I hope you have liked it. If you want to run locally on your computer, I have attached in GitHub repo link. You can clone and run directly on your computer. If you have any problem, you can comment it down. Thank you for watching.